Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss another one topic related to flow measuring devices, which is known as rotameter. In our previous lecture, already we have discussed regarding the flow nozzle or nozzle meter, and now this lecture will discuss about the rotameter. So rotameter also another one device which can be used to measure the rate of flow or discharge. Okay, so here a diagram related to this rotameter I've kind of taken from the internet. And if you see the structure of this rotameter, so this is the inlet part of this rotameter, and through which the liquid is to flow. And this is the pipe connection is there. So pipe is connected, suppose like this, and the liquid will be flows through this. Okay, and so this is the inlet part of the rotameter, suppose you can say, and this is the outlet part. Okay, outlet in the sense I have taken this scale level up to here. From this is the bottom level, and this is the top level of the scale, and this is the this pipe is connected. So here we can show this is the outlet, and this one we can say this is the inlet part. So the liquid which is coming inside this rotameter, so the liquid will be continuously flows through this pipe, and after flows it is to go out through this outlet. So this is the working of this fluid when it is flowing through a tube. So what is the work of this rotameter when the liquid is flowing? So as I told you, the rotameter is used to measure the rate of flow or to find out the discharge of the liquid when it is a flowing condition. Now for this, what are the other parts are there? You can see there is a tapered glass tube is there, and which is transparent. This tapered glass tube, as it is made of glass, so it is transparent. And this is one thing, and this one is known as float, or it used to called as a rotor. This is called one thing is called float, or also called as rotor. Okay, and there is a measuring scale is there. So the scale is to from bottom, from this bottom to top, there is a measuring scale is to there. So which will be gives the value of rate of flow. So there is a measuring scale, or you can calibrated scale is there, that is called as a calibrated scale. And this line is the called as guide wire for the float. So that is the, you can say, one kind of axis line for this float or for the rotor. Okay, so this is about the all these parts which is related to the rotameter. Okay, now this rotameter also is called as a area meter. This is also called a area meter, and as I told you, it consists of a transparent vertical and conical tube, and which is vertically placed, and there is a float is there. This float will be floats, or it is floating on the water when there is a fluid flow is there. Otherwise it will be on the bottom side. Okay, so this is about the flow measuring devices of rotameter. And this float, actually this float is a little bit heavier. This float little bit heavier than the liquid which is flowing, so that this float used to always sink in the liquid. It may be water or any kind of liquid, so that's why it is always sink in the water or in the fluid. Okay, and then when the liquid is to flow in this, then it is to give a force to that to move upside. Okay, otherwise it is to settle on the bottom side. It is to be like it is to be placed like this here. Okay, so when there is a force, the fluid is to flows on this, so there is a pressure force which will be acting on this vertically upward, then it is to go up. Otherwise it will be settled on the bottom side. Okay, and while flowing, there is two types of forces are acting on this. I'll tell that one. And this is all about what I told you, the working principle of this rotameter. So when the fluid flows through the tube, or you can say the rotameter, the rotor lifts up and reaches a maximum top level of this. Okay, and here, as I told you, this is the calibrated scale, so all the values can be measured here, like 1, 5, 10, 15, 20. So this kind of scale measurement is to given here so that we can identify so at what level or what is the rate of flow on this. Okay, so when the fluid used to move, started moving here, okay, this rotor or this float is to it is to shuffle, like you can say, or it can be displaced here and there. So once the flow started, then this float may be up and down, it will be kind of continuous flow is there. So after some time, okay, it used to have a balanced position. Okay, this rotor used to have a balanced position after the flows continuously having some duration, some time, you can say that one. And here another one point is there, that is this float or rotor can be balanced in a particular position, and there is a rotating motion is to work on that. Due to the rotating motion, the float or the rotor helps to keep in steady condition. So that is another one concept is there, rotating motion which is acting on the float or rotor, so that the float can be in the steady condition. So in this position, if this float should be in this position, so there is a equilibrium condition is working on that. So that is nothing but the downward force of the rotor, or on the rotor we can say. So we can write this downward force on rotor equal to upward force on rotor. Okay, that means, see, as it is placed vertically, so there is a gravity is used to work on this, so that's why it is to goes always down. So this is the downward force of this rotor which is acting on the, or we can say the weight of this rotor also acting on that. Due to that, it goes vertically downward, it goes down. And when the liquid flows, so there is a force acting on this rotor, and that's why it is to move upward, or it is to goes upside. So this downward force on the rotor and upward force on the rotor, it should be equal. Then when it is both are equal, then this rotor or this float will be in the steady condition. Up to that, it will be in a move up and down, it will be a moving condition. Okay, and one more term also there, I can say that one, the hydrostatic force on the rotor, on the upper side of the rotor, hydrostatic force on the upper side of the rotor plus the weight of the rotor. Okay, two things, the hydrostatic force on the upper side of the rotor plus the weight of the rotor is equal to the hydrodynamic or the hydrostatic and dynamic thrust. Let me write hydrostatic and dynamic thrust of, here it is, we need to consider water, because that is the medium which is acting on the rotor. Hydrodynamic and dynamic thrust of water or liquid, you can say, on the underside of the rotor. So this should be equal, so that we can say this, this rotor will be in the balanced, or it will be in the steady position. Okay, so these are the two conditions are there. See, when, as I told you already, informed you that when the flow is liquid is flowing in that, so it used to reach a maximum limit of this, and there also we are having some scale values there. So by that scale we can see, okay, at what rate of flow it is flowing, so directly you can measure from there. Okay, that is one method to identify the rate of flow. Another one also equation is there, that is, the Q equal to, there is a value of K into A, and that is root over of GH. So this is also some equation, like one equation is there, sometimes it is to also use. Okay, otherwise we can find out from the scaling also. And here this K value is a constant one, and this is the area this is the area of this float and this this tapered tube. This area we need to consider that one. And G is the gravity, as we know, and H is the pressure drop. Okay, this is the pressure drop. Another one pressure drop need to be like manometer type will be there. From there we can see the pressure drop value. So then we can calculate the discharge. Okay, so this is the method of to calculating the discharge and what is the working principle of the rotameter, as I told you. Along with that, we'll discuss some application of that application of this rotameter. So application can be used in many cases. There is no simple single or one or two places are there. It is having multiple number of applications are there. So first I'll tell you about the industry. So any kind of industry it can be used, either maybe mechanical or maybe chemical or maybe oil refineries. Okay, so industrial application I can say. And second one I can say any kind of laboratory also we can use this one for measuring the flow. See, this laboratory may be academic lab or maybe research lab, so that can be in this lab also can be used. And next I can say in the analyzer or gas sampling also we can use this one, analyzer or gas sampling. And next, the most important thing, also we can use in the medical application also. The medical application to find out to measure the oxygen flow rate, we can also use this one. Okay, so these are the few examples I told you, and along with that I'll give you some advantages and disadvantages of this. Advantages of this and disadvantages of this. This is quite simple, like you can easily identify also from this advantages and disadvantages. By seeing this setup, you can see this is very simple. Okay, very simple in design. I'll write this point only so that we can identify this is a positive one, positive comment. So simple in design, you can say. The cost, obviously if I'm writing in this advantages sides, obviously the cost will be less one. Okay, so cost is less. And the pressure drop, so less pressure drop is to there, or low pressure drop, we can say low pressure drop is to there in this. And it's easy to operate. Operation is easy, operates easy, and it is versatile. Okay, it is versatile, we can say. You can see this very simple in design. Okay, and very easy to understand and very easy to operate this one, and very easy to identify this value of this rate of flow. And one more thing, there is no external power required or any kind of external fuel required to move this one. Okay, very simple. We can just like that with the help of this rate of flow, it will be started moving up. Okay, so no external sources are required. External sources not required to work on this. And simultaneously some disadvantages also there, like it is to always need to be kept in the vertical. It is to always kept in the vertical position. That is one disadvantage I can consider. And this will be not suitable also for high viscosity fluids. The normal fluid is there now. Okay, for high viscous fluid it will be not used. Okay, and similarly, and it will be having a limited accuracy for high flow rates. Even accuracy matters when it is coming for the high flow rates. Accuracy matters. So these are some points are there for the advantages and disadvantages and applications. So I hope you understand this lecture. If you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.